Okay, so example question. First one, a 1.5 volt cell is used with a 300 millivolt, 75 ohm component. What potential resistance is required? So 1.5 volt cell, 300 millivolts, 75 ohms. These are the things you need to think about. So 1.5 volt cell, 300 millivolts, and 75 ohms. So we've got a cell at 1.5 volts. We have a component. Now we don't know what the component is exactly. It could be an LED, could be anything. Let's just say it's an LED, just for the sake of, because we're talking about LEDs and protective circuits. It could be almost anything. So if the current's coming round, the current will come round this way, and it must go like that.
So, usually we can call a resistor.
Uh-huh.
They have a big R in it.
What do you mean?
I was in the equation had an off and
the homework had a big massive R in it.
Inside the resistor. That's just telling you R for resistor.
R.
So LED current flows around this way. LED we're going to say is 75 ohms, so it's probably quite a high value for LED, and it's 300 millivolts is what it requires to use. 1.5 volts here, 300 millivolts here. Now, so what do we need to know here? Current, Craig's got it, current. If we calculate how much current is safe for the component, the LED, then we can calculate what resistance is going to lower the current to that level. So this is the thing about series circuits. They always calculate the current because the current is the same through every component. So I'm going to calculate the current for that LED, what the current requires. So V equals IR, I equals V over R. Guys, stop talking, I'm talking. V is 300 millivolts, which is 300 times 10 to the negative 3. Or you can try and work it out with zeros, but it's probably easier to say 300 times 10 to the negative 3. And R is 75. Calculator please, somebody got their calculator? If not, then get your calculator out. Work it out please. I is going to equal to what? What is it? Go on then. Gillian, what is it? 2 minutes. So 4 times 10 to the negative 3, which should be 4 milliamps, equals 4 milliamps. So 4 milliamps, okay, 4 milliamps is a current that needs to be in this circuit. Guys, come on, settle please. All I have to do is get a calculator out.
I'm listening, sorry, my math.
Right, we'll make sure you bring physics next time. So 4 milliamps is a current that needs to go through this LED, which means 4 milliamps is the current which needs to be in the whole circuit to protect the LED. Okay, so 4 milliamps is what we need. So we have got a component resistor here. What can you tell me about what's happening in the resistor? What properties are there of the resistor? So it needs to have 4 milliamps. We want to know the resistance. What else do we need to know? The voltage. We do, yeah. So if we want to know what resistance it is, we need to know the current and the voltage. Right? So let's do this at the side here. We want to know our R value. So we need to know V and we need to know I. I we already know. I is going to be 4 milliamps, so it's 4 times 10 to the negative 3. V we already know as well. How do we know that? What is the rule for voltage in a C circuit? Daily. Current is the same at every point, then voltage must be the opposite of that, which was you'll only do like the 2 different rules. It's not one, it's the other one. Add them up, great. Okay, so it's the same at every point when you add them up. So voltage is adding them up. So 1.5 is your supply, 300 millivolts is the LED, so how much voltage do you want through the resistor? Sorry? So how did you work that out? Millivolts. 1.5 minus the 300 millivolts. So 300 millivolts, if you were to write that in standard units, you're going to get, millivolts times 10 to the 3, 1, 2, 3, so it's 0.3 volts. So the voltage through the resistor is going to be equal to the 1.5 minus the 0.3. So it's going to be 0.2, 1.2.
Yeah, but that's the other
Yeah, but that's the total voltage. So that voltage is split between this and this. So it's what 0.3, that's 1.2, give you 1.5. So 1.2 there, 3 equals IR, R is V over I, equals 1.2 over 4 times 10 to the negative 3. Do that please. So R value is 4. I thought you were going to say, just do the summing. 300, okay? So R is 300 ohms. Now, that's example 1. That's example 1. We're going to have a go at doing some of these in a minute. But before we do that, let's go back to that question, okay? Just so we all are clear.